Geometry and measurement diagrams are not scale, not to scale. Let's have a look. In the diagram above, x equals, so you had to find this angle. You had to know that the angle sum of a triangle was, angle sum of a triangle, 180 degrees, there. So in order to find x, you take away the other two angles. That right angle there is 90 degrees. You got your 25 degrees there. So that's why you subtract, you end up with 65. Question 2, same idea. Almost exactly the same, except it's not the angle sum of a triangle, it's the angle sum of a revolution, which is 360 all the way around, right? So that's where you got this 360 here. You take away your other two angles, and you end up with 209. Going down here to question 3, you've got your parallel lines here, okay? So you might have done a bit of working on the page. You might have noticed that x and this angle up here, they're the same. So you can call that x degrees. Why is that? Why are these two angles the same? What kind of angles are they? We've got three kinds of angles on parallel lines. You've got corresponding, you've got co-interior, and you've got alternate. Okay. Now, what are the shapes that correspond to each one? Corresponding is the F, co-interior is the C, and what letter did you get from the alternate angles? Do you remember?
Z.
It's the Z or an N, depending on which way you draw it. Okay. So if I'm looking at these two, that looks to me most like it's an F. It's just kind of slanted over. Can you see that? So that's why they're corresponding angles. That's X and that's X. The angle sum of this line here is 180 degrees. So that's why the working out is 180 minus 135. Okay. It's not the only way. Alternatively, you might have said that X is here as well, because what are these two angles? They are vertically opposite, so they're equal. And then you get co-interior angles here. Same thing, 180 minus 135. In the diagram above, this is what we looked at before. Co-interior angles, right? So that's why you've got 180 minus 43, because co-interior angles are, what's the word? Starts with S. They're supplementary, which means they add up to 180. X plus 43 equals 180. And you can see when they take 43 from both sides, that's what gives you this line. Okay. Over the page. The perimeter of this figure. So perimeter, you have to add everything up. They do give you all of the sides, every single one. Okay, so you can add all of them up and you'll get 26. I'll give you a bit of a sneaky clue, by the way, sneaky trick you can use. Look at this shape. It's a weird looking shape, right? But do you agree that if I change the shape a little bit, for example, if I compared it to this, see that 3 meter? I'm going to put it over there, and this 4 meter, I'm going to put it over there. So now what I've got is a rectangle all the way around. Do you agree that the rectangle that I've just drawn and the original shape, they have the same perimeter? Can you see that? I've just moved those sides to different places. Well, rectangles, their perimeters are really easy. That's 6 and that's 7. The perimeter of a rectangle, you just have to double both of those. That's 13. You double them, you get 26. Same thing. Okay. So sometimes when they don't give you lengths, you can take advantage of the fact that a shape like this, you can compare it to a shape that you do know. Rectangles are easy. The area of this figure is, it's made up of two figures, so we have a name for this. It starts with a C. Do you remember? When it's made up of two shapes, we call it a composite shape. We've shoved it together. A rectangle and a triangle. Okay, so you can see they've got the rectangle here, 6 times 5, and they have the triangle here. This is length times breadth, and this is base, half base times height. So you've got the 4 there, and that's 6 across there because it's opposite that side. Okay, so that's where you get those calculations. 12 plus 30 gives you the 42. The circumference of a circle is given by this formula. That's nice that they handed it to you. Calculate the circumference of this circle to the nearest centimeter. So all you had to do was take that formula and you had to stick in r equals 5. So you can see that. Okay, it was just one mark. You could just do it on your calculator, and they want it to the nearest centimeter. So the 0.4 rounds down. That's why you get 31. The area of this triangle is 84 centimeters squared. What's the height? So here it was a bit tricky. Before you had height and base, and then you work out area. But here they give you area and base, and they want you to work out height. So it's a slightly different thing. You start by writing out the area formula, like so, and then you fit all the numbers in where they belong. And that gives you your final answer.